So one of the things that we looked at when we were looking at implementing material design were these two concepts of authentic motion and responsive interaction. And these are two concepts that are in the material design documents. Authentic motion says that things that move in the digital world should actually move like they would kind of in the real world. It should move authentically. If you look here in this GIF, you can see that the ball on one side is moving at a linear rate from the beginning to end. This feels mechanical. It doesn't feel like something that's natural occurring in the world. The one on the right is easing in and out. This feels more natural, and when you're developing animations, you want to make sure that you're implementing proper easing of those animations to give it the feel of authentic motion. The other concept is responsive interaction. What responsive interaction tells you is that when you're interacting with something, it should respond immediately. You shouldn't have any delay. When you touch something, it should immediately respond. Not only that, but once it responds, it should respond in a way that's logical. It should do something that follows a set of rules and makes sense. So I'm going to show you an example of that authentic motion and responsive interaction in something that we developed. So this here is a browser window that was a common component on the sites that we built. Pretty much every page had this window, and as we navigated between slides, new content would animate in. When we left the slide, that content would animate out, and new content would animate in. So I'll go ahead and animate that. Sense of what's going on. So as you can see, content animates in, and when you leave the slide, content animates out. But what you probably can't tell here is that all this content is moving at different rates. It's all eased differently. The idea is to give this content, the animation of this content, a feel of authenticness. In the real world, things don't move at linear rates. Things don't happen all at the same time. It's organic. So if I slow this down, you should be able to see more of what's going into this. So here's the animation slowed down. As you can see, the logo's animating at a different speed, starting at a different time. The partner's badge here starts maybe like halfway through the animation. As it animates in, this content responds to that animation. So that's the concept of authentic motion, giving something a feeling of organicness. You do that through easing and just proper choreography of your animations. So the other concept was responsive interaction. So with responsive interaction, as I mentioned, you want things to respond immediately. You want them to be fast. So this animation, as you can tell, it's super fast. You almost can't tell that it's animating, right? It just feels like it just happens. When we started working on our prototypes, the only place that we had to draw from for inspiration was the material design video, which is actually really, really slow. This ended up being about 4 times faster than any animation in that reel, because on the web, we want things to respond super fast. If you don't, your app feels laggy, and it just doesn't feel responsive. So one of the things that was really important for us when we were creating these animations was designing the browser. There's multiple reasons for that. One of the reasons is that we need this thing to work on a huge number of devices, right? you can't figure out an animation like in After Effects on all these different devices. You might as well just develop it in the browser and look at those devices and see how it's responding. One of the big challenges of developing in the browser is that the DOM is really, really slow. It can't handle a ton of things happening at once. It can handle animation, but it can't handle like a ton of animation and then loading in Ajax and JavaScript doing garbage collection. Flat out, it's going to be slower than native devices. For that reason, when you're creating animations in the browser, you're going to have to optimize as much as possible. You're going to have to find those parts where the animation is slowing down, figuring out what's slowing it down, and then either optimizing what it takes to create that animation or figuring out new solutions if that's not possible. So one of the techniques that we used was we set a performance benchmark. Our performance benchmark was 60 frames per second, which is kind of a magic number. If an animation is performing at 60 frames per second, it's going to feel smooth. It's going to look like motion that's happening in the real world. Realistically, anything under 30 frames per second, you're going to perceive a hiccup, but we shot for 60 for that kind of ideal. Anytime we started hitting hiccups, we had to look for ways to optimize our code and make our animation smoother. So the way that we chose our 60 frames per second benchmark, and then we chose the devices that we were actually going to test on. We obviously couldn't test on every single device possible, so we tried to choose a set of device classes that was realistic. These were prototypes, so we kind of had best case scenarios, but in the real world, you're going to want to find what devices are actually being used on your website, because you might have devices that are being used that might not be able to perform the animations that the designer comes up with. One of the ways that we optimized performance was to use CSS for animation. CSS is fantastic for animation when you're talking about toggling simple states. Like a great example for a use case for a CSS animation is a hamburger menu, where it has two states, an off-screen and on-screen. So we're toggling between two states. CSS animations are easy to implement, and they're also super performant when they're done well. So one of the ways that CSS animations perform really well is if you use this set of properties: position, scale, rotation, opacity. And the reason you want to choose these properties is that when you're using CSS animation on these, the work is actually offloaded to the GPU. Your CPU is freed up to do other calculations, and your device's graphic processing unit will handle rendering those animations. So you can use these CSS properties like transform translate, transform scale, transform rotate, opacity to do your animation, and you're going to see better performance than what you would do with JavaScript. So here's a kind of example of the difference between animating with those properties I mentioned and animating with other properties that are more difficult for the browser to render. So in this video, we have a MacBook that's being animated with the top and left properties of CSS. And as we add more and more elements to this animation, it gets laggier and laggier, which tells us that the browser is doing something. In this video, as we add more MacBooks, the animation stays smooth. That's because we're using Translate to do this animation. One thing to keep in mind if you're doing this kind of animation in CSS is the null transform hack. What the null transform hack does is to be applied to an element, it then tells the GPU to handle the rendering of that element. The null transform hack is applying a 3D CSS transform with no value to an element. In this case, we're applying translate Z to this element. The rendering of it is now going to be handled by the GPU, and animation of it should be faster. Keep in mind, though, that this technique might not work everywhere. On mobile devices, the GPU can actually struggle with handling some of these animations, and it can actually be slower. So one of the properties that Google has been championing lately is the will change property. And what the will change property is it takes the value of what property might change in the future. In this case, I set it to background color. I'm telling the browser, in the future, the background color might change. And what the browser is going to do is it's going to say, okay, maybe I'll offload that rendering to the GPU. Maybe I'll do something else based on whatever my device capabilities are or whatever the situation is at the time. It's not super well supported yet, but it should be definitely better than this ugly hack. So one thing that I wanted to talk about that I don't see that is used very often is transitioning transforms. A lot of people don't know that you can actually do that. I don't know if you guys can see this code. But what we have here is we have just a super quick mock-up of off-campus menu. We have, in the CSS, we have a transform that's telling it to translate 100% off-screen. And then we also have a CSS transition applied to that. That's telling it to transition the transform. But what a CSS transition is it's a simple animation between a start and an endpoint. Saying, handle the animation between two different states. So I'm going to apply the translate and the transition to this off-campus menu. So now I've applied the translation to the menu, so now it's off screen. And then with JavaScript, it's just toggling a class to bring it back on screen. JavaScript's doing nothing else other than toggling a class. This is the most performant way that you're going to be able to do animation on the web. Is use these CSS transform properties and also utilize CSS transitions. So CSS animations are great, but they're limited. They don't have a lot of power. We can't stop them, reverse them, rewind them. We can't choreograph them without jumping through a lot of hoops, and that's where JavaScript comes in. If we want to track events such as touch position and stuff like that, we're going to have to use JavaScript to do animation. You can still use JavaScript to toggle CSS classes and do animations with CSS, and that's a great way to kind of choreograph your animations. So for our project, we used GreenSock's TweenMax. It's a JavaScript library for animation. It's based on the concept of timelines. You might be familiar with Flash. There's a timeline in Flash. And in the timeline, you place objects, and then over the timeline, you tell them what to do. This is an example of GreenSock. As you can see, there's a timeline. You can play, pause, reverse the animation, restart it. So that we use GreenSock to really kind of choreograph our animations, and where we couldn't find CSS animations that will perform it, we use GreenSock to figure out those animations. More code, I hope you don't mind. So back to this browser example. But here's the JavaScript to perform the animations with GreenSock. And the way that we did it was each element in this browser had its own timeline. Actually, several timelines. One timeline would handle the state for it to come into the screen. One timeline would handle the state for it to come out. Under those individual timelines for each element, we had timelines that were specific to each state of the browser. So each slide would have its own timeline to handle that browser's animation. And that way we could just trigger that master timeline, and that master timeline would trigger all the timelines of our elements within. Finally, we had like one global master timeline that would handle playing everything. So that's how we handled the JavaScript animations. We handled choreographing all of our animation. One thing that we did ruthlessly while we were creating this project is we constantly profiled the performance. Chrome has really good dev tools for doing this. Under the timeline tab, if you open up the dev tools, you can actually record the frame rate of an animation. This image here is a recording of the animation that I was just showing you guys on the browser. It records over time, so you can run an animation multiple times, and it's going to record the events over time. And it's going to show you the frame rate of that animation. So in the timeline here, we have a graph. As you can see, there's our benchmark of 60 frames per second. We strove to actually be under that frame rate benchmark as much as possible. And as you can see in this example, we did. So as we worked on the project, we constantly tried to optimize our animations so that we would be below our frame rate benchmark. So when you're developing animations and you're actually profiling them, you're going to probably hit areas where the animation is slow for some reason. And it's going to be represented in this graph. What you're going to be able to do is then click on those areas where it's slow and find out what the browser is doing when that slowdown happens. And that's what this waterfall graph here does. You can find out where the browser is taking a long time to do things, such as calculating repaints, do various things, maybe doing garbage collection or something like that, maybe animating a CSS property that's not performant. Once you track that down, you can look to optimize it, or you can remove what's actually causing the animation slow. So if you're building animation on the web, test often. You have DevTools open all the time. You can do this on mobile devices too. You can debug mobile devices with the Chrome DevTools, and it will show you the same information. So, some takeaways from my talk today. I hope you understood the importance of designing in the browser and working very closely with your design team. If you're taking on a project like this, it's not going to typically be something where you're going to be able to take a bunch of designs and then implement those designs. You're going to have to work closely with your animation team and continually refine your animations and your design. Something that is going to have to be built into your project to achieve at a high level. Test all the time. Test while you're doing these things, find out where the slowdowns are, and fix those things. Set performance benchmarks so that you can understand what you're testing against. Find out what device classes you want to test on, and constantly test against the performance benchmarks and optimize your animations so that they're going to look good. Finally, work on your motion design skills. There's no tools out there available for a designer to communicate these animations to us right now. In the old days of Flash, it used to be that a designer could build animations and those could immediately be put on the web. But nowadays, we need to take animation designs and actually code them up. And a lot of that work is going to have to be done by the developers. So looking towards the future of material design and front-end development, we can expect more users to be on better devices. Devices are getting better all the time, they're more powerful, they're getting optimized for animation. Things have gotten a lot faster already. It used to be like, for example, Box Shadow was super slow to animate. Now it's actually pretty quick. More users are going to be on evergreen browsers. Those browsers are going to update automatically, so even IE is going to be evergreen. So we can expect anytime we have problems with animations or new types of specifications, ideally the browsers are working towards making it easier for us to do. And finally, I would be remiss if I didn't talk about web components and Polymer. I'm talking about material design and front end. Polymer is a JavaScript polyfill for web components. and it contains a whole set of libraries of elements that are built using material design specifications. So the idea is that you'll be able to take elements and plug them right into your website. Those elements are going to be performant. You're going to have a simple API to use, and you'll be able to plug them into your website and just use them right out of the box. And we have a talk, I think, after this, but so that's my presentation for today. My name is Blon. Here's a couple places you can find me on the web, and I'm happy to take any questions.
I'm curious how you manage the definition of done for, I don't know if you use user stories or whatever, working back and forth with the designers, because I can see how that can just scope creep, you know.
Yeah, it's a really good question. Luckily we had kind of deep pockets for this one, working with Google, I think. The agency expected a lot of back and forth. That was kind of the agency's MO. Pretty much any project that they did, they expected to kind of be working closely with their development team to map the designs and stuff like that. But if you did have a situation like this where you needed to create these type of things, I would definitely kind of identify the critical areas that need to perform. So identify the critical pieces of your site that need to perform well, and then work towards that. And then when that's done, then you're done.
Sorry, I actually had two questions. First one was, we're coming with 60 frames per second. Was that client driven, or was that you driven, or is that some kind of research?
Yes, it's a standard that Google promotes, 60 frames per second. There's a developer on the Chrome team named Paul Lewis who talks a lot about the 60 frames per second benchmark. He strives to hit that 60 frames per second when he's developing sites. They just released the Google I/O 2015 site, which was very material design focused, and it looks pretty close to 60 frames per second.
One reason people often go 60 frames per second is that's actually the refresh rate of almost every screen. Almost all 60 frames.
Thank you. So that's a question that I've seen it a couple times and I didn't know what it was. The other question I have is, I was going to originally ask how you're measuring it, but you told me with Chrome, with the Chrome tools. The next question I have is, do you feel like Chrome is enough if you're going to be designing outside of just the Chrome environment? Like, I hate developing to IE, but you know, sometimes you have to do it. And how would you test it there? Or do you think that's not necessary? You think Chrome does enough today?
It's absolutely necessary depending on whatever your project is. If Internet Explorer is in scope, then you should definitely be testing in Internet Explorer. I'm not sure.
How do you hit your benchmarks there? That's my
question. No, that's a really good question. For this project, Internet Explorer wasn't in scope, and we didn't have access to those type of tools. Yeah, I'm sure that there's some sort of profiler or something like that. You just got to work really hard to figure out how that's going to work.
Okay.
I was going to ask a similar question. I mean, do you use something like browser stack to sort of determine which of the material design elements are going to work, particularly for animation, on the spectrum of, let's say, current values?
Right. That's a good question as well. We identified kind of key devices that we're going to test on. So we test on like Nexus 5, modern iPhone, and then so we tested on those constantly and had those devices available to us. If those devices were in the scope of the project, probably we would also be testing on those and have those devices available to us at all times. And then if problems came up down the road where something wasn't working, we'd have to get that device in test and optimize from there.
Okay, so, sorry,
Sure.
annoying one. So when you're talking about benchmarking, in Chrome I know that you can actually emulate different pieces of hardware. Did you actually have literal hardware devices and do you both?
Oh yeah. Yeah.
So
you can emulate the hardware, so you can emulate the size of a device, for example. But you're not going to emulate the hardware of that device. You're going to have to actually get the device and use it. It's the only way to actually test and see how something is going to perform.
Right. So I had assumed that you were talking about using Chrome's emulation in order to do that, which works with question I had. So is there a test suite for mobile devices so you can check what's going down?
Yeah, so in Chrome DevTools, you can actually debug using the Chrome DevTools on mobile devices. So you can actually enable the DevTools to inspect what's going on in the mobile device. You just plug it into your computer, enable mobile debugging, and it's going to show you the same information, like the same timeline information.
Thank you.
Anybody else?
Can you speak to how you structured the project team? The role of the designer, the material designer, and then the developer, you know?
It's a good question. I didn't actually structure the project team, but the role of the designer was, in this case, they came up with this, basically the visual design of the site. So we got the beginning and end states of all our slides, and then we also had some sort of guidelines as far as how those elements in a slide might move. And then it really was the developer's roles to kind of implement that, figure out how those animations would actually, like the duration of those animations, how the pacing would work. And then we went back to the designer and they would kind of give us their feedback as far as whether we were hitting what their expectations were. Yeah, so it was really interesting because it was a super collaborative effort, and it wasn't a typical waterfall type of project that we usually get, where we get all the information and then develop it. We had to kind of all work as designers, so we were all a little bit of designers.
Any guidelines for estimation?
That's a good question. You're just going to have to go in with a realistic expectation that you're going to have to go back and learn. Might be the type of thing where you are, the project you take on is more like you're going to be working over time on this thing rather than you're going to be completing this specific thing.
Yeah. Is Polymer considered a framework for material design, or what's the framework that you use to build material design?
So for our work, we just use straight up HTML, CSS, and JavaScript. Polymer is a polyfill for web components. Some of those web components are based on material design. In Polymer, you can actually use those web components in your sites today. So Polymer provides web components that are based on material design that you can use on your site. Obviously, those are components. They're not like complete, for example, animations and